Okay, guys, so looking at sections 6.4 to 6.6, we have logarithms for all three of those sections. And in this short video, we'll just discuss bits and pieces from these three sections. We're not going to thoroughly cover all three sections, of course. And we start with the definition of a logarithm. So definition, the expression log base a b, the expression log base AB, you guys can jot this down here. The expression log base AB is defined as the exponent that will turn A into B. And then it says both A and B must be positive. So with this definition here in mind, we can do some examples where we see how to evaluate logarithmic expressions, but with no calculator. So example, evaluate without a calculator. Okay, so let me drop this off like over here somewhere. You guys can copy all this down while I speak. And let me write down some expressions here. And we wish to be able to do these, but with no calculator. So for example, let's say for part A, we look at log base 5 of 25. And I suppose I can put parentheses like that. And so here is how this expression is to be interpreted. Okay, so look, this is called the base right here. And this is called the argument. Now the base wants to become the argument, and it is a matter of exponents. So for instance, 5 needs to become 25. So what exponent do you have to give to the 5 to turn it into 25? Well, we can all agree that that would be 2. And that's why this equals 2. What about up here? What if it says, let's say, what if we have log base, let's go with 3 of 81. So it's the same game that we play. 3 to what power becomes 81? That would, of course, be the number 4. Because what's 3 to the power of 4? 81. What about this one here? What if it says log and it just says 1,000? Just like that, right? Log 1,000. Well, see, here's the thing. Usually there's a subscript A. Like in this case, there was a 5. Up here, there was a 3. But this one's empty. There's no subscript A being specified. Anytime that's the case, we tell our students to put the number 10. That's always what you put in the event that no such base was specified. And then we can play the same game. 10 times 10, how many 10s have to multiply? 10 to what power turns it into 1,000? For sure, the number 3. And so you guys can see that looking at these statements here, for instance, I know that this is true because I can test this. I can say 5 to the power of 2 equals 25. I can say, hey, 3 to the power of 4 equals 81. I can say 10 to the power of 3 is 1,000. You see that? So what we can say now is we can establish a certain conversion. So let me wipe the screen clear. And we can say this. We can sort of title this little snippet. We can title this converting between forms. Okay. And we're going to have log form on one side, and we're going to have exponential on the other side. So let's make this look like this here. And let me just leave this here like in the top left. Leave it right there. And here are the log forms and exponential forms. So this is the heart of this lesson, as I told students yesterday. So here's log form. We have log base A of B equals C. And so if you do have something that looks like that, then that's in logarithmic form. But what we can do is we can write it into exponential form. So let me use a different color for that. How about we go like red here? Exponential form would say this: a to the power of c is equal to b. And you and I are going to go back and forth between these two forms for the duration of this video. So this is log form, and this is exponential form. And why don't we do just some conversions here so that we can get comfortable with how to convert from log form to exponential form. So let me sort of separate this because this is going to be up there for the rest of this video. And let me open up a text box. Let's do a couple of illustrations. So example, convert to exponential form. Okay, so hopefully you guys are jotting this down. This is pretty much what I did with the class. I might go through it a little bit faster, and I might sort of skip a little example here or there, but you really get into the gist of it all. Right, this is just a little bonus video. So for instance, for the first one, let's say you have log, and let's go, how about 6 to 16 equals 3? This is a true statement. So what would this look like if you were to write this into exponential form? We'll apply what you see up here in this bubble. I'm trying to go from here to here. Doing so, it would be 6 to the power of 3 equals 216. Done. Right? What if it said this for part B? What if it said log? And what if there was like letters like R and then J and then equals like W? What would that look like if you were to convert this into exponential form? It would go R to the power of W equals J. What if instead it said like W plus 1? Well, that would have just been W plus 1 up there as the exponent. You see that? So this is how you convert from log form to exponential form. So why don't we do the same thing, but like completely backwards? Yeah. Let's go from exponential back into log. And so let's see if we can just change the directions here. So it'll say convert to log form. So let's do the same thing, but backwards. Let's do the exact same thing, but we'll put this in reverse. So for example, in part A, here's the fact: 3 to the power of -2 equals 1/9. So this equation, this statement, is currently in exponential form, like that, but you want to write it in log form. And if you follow this procedure in log form, it would look like this. It would go log base 3, 1/9 equals -2. What if it was something a bit more arbitrary? Like what if it said like Q to the power of A minus B equals T plus H? Strange, but this is an exponential form, and we want to write this into logarithmic form. And so it would look like this: log base Q of T plus H equals A minus B. Done, right? So this was just a demonstration of how to convert from log to exponential or vice versa. So what is even the point of logs? The point of logarithms is to be able to solve equations that cannot conveniently and quickly be solved. So let's wipe this screen clear here, and let's do some examples of solving equations. So it'll say like example, solve each equation. And let's do a few equations here, shall we? Let's put this up there, and let's write down some equations here. So how about this one here? Let's go with, how about like 5 to the power of W plus 4 equals 25. So notice that for this equation here, I think that I can do this equation without logarithms, which is why I chose this equation to start with. So for instance, this is 5 to the W plus 4. On the right-hand side, it says 25, but nuh-uh. Instead of 25, I'm going to go 5 to the power of 2, because now I have a 5 and a 5 and they match. And because the bases match, I can go, hey, that exponent has to equal the other exponent. And so if I subtract 4, you see I'm done. W is -2. I was able to do this equation without logs. Okay, how about this one? What if I go, let's go 2 to the power of w is equal to 10? Do I have the ability to take the 10 and to rewrite it as 2 to the power of something? I don't. So I don't know what to do, right? Like in the first example, I just turned 25 into 5 to the power of 2. For this one here, I don't know how to rewrite 10 as 2 to a power. So we cannot do what we did in example A. However, we can write this into logarithmic form, right? Right now it looks like exponential. So look at your notes. And how do I go from exponential back into log? Well, you just did a bunch of examples like that. So if you write this into log form, it'll say log base 2, 10 equals w. Right? And what was the point of that? Well, the goal is to get w alone. And look, voila, w is alone. All you've got to do on a calculator is type that in. Type these into your calculators, and whatever decimal you get, you can just round it however you want. So the suggestion is, if you have something that looks like in log form, write it in exponential, and vice versa. So this is in log form, and if I rewrite this into exponential form, it'll go 4 to the power of -3 is equal to x, right? Going from log to exponential. And then just go calculator here, and it'll say 1/64. Yeah, it'll say x equals 1/64. So the key is to convert from log to exponential and vice versa. What about this one here? What about log? Let's go, how about we go base x, and then it says 1/32, and then it says equals 5. So let's try this one here, and let's rewrite this into exponential form. So if you write this into exponential form, it'll say x to the power of 5 equals 1/32. And that's what it'll say there. And we're trying to get x alone, and it's almost alone. You just have to make that power of 5 disappear. And so to make that power of 5 disappear, what we would have to do, guys, is we would have to take that fifth root of both sides, right? You'd have to take a fifth root. Because on this side, it would just be x. And on a calculator, see a lot of calculator for these 3 sections. On a calculator, it would say 1/2, right? On a calculator. And there's one thing that I have to show you guys before we finish this tutorial. And that is there is this one thing that we call, it's called the change of base. The change of base formula. I have to throw this at you guys. I did this to all my students. I showed them this change of base formula. And it basically says this. It basically says that log base AB, that is the same as log B over log A, right? So you really, really, really want to jot that down. This is a really convenient formula. Because here's the thing. Sometimes students have a calculator where the calculator, it does have this button here. It's so clutch. Having this button is really nice. Like on a calculator, you would literally see a button and it would look like this. It would be log, it'd be a little baby box and like a bigger box. See that? So if you have this guy here, you can type in anything. But some students don't have this button, and it's not fair if I ask them to do homework where it has this. So it's all good, because if you don't have this button, you can just do this instead. For example, if I were to ask you, take out your Casio calculators and type in this here, if you were to type that in, your Casio would say 3. But what if you don't have this button here? Then do this instead. Instead of typing this, type this in instead. Type in log 64 over log 4. See that? And I think everyone can do this because everyone has like the regular log button. So you just go log 64, hit equals, and then divide it by log 4, hit equals, and it'll say the same number 3, right? Like you might have to turn your iPhone or your Droid sideways to see the log button, but it should be there. Even like if you go to Dollar Tree and get a cheap little calculator, it'll have the log button more than likely. So this is called the change of base formula. So if you can't type this in instead, because it's the same thing, they're equal. And so why don't we finish this video by looking at the idea of inverses. So the directions here would say, find the inverse of And let's do two examples here, one of each type. So a few lessons ago, we did inverses. And in the previous lesson, we did exponentials. And today we're doing logs. And now we can tie all those concepts together with a couple of examples. How about this here? Okay, so I'll let you guys copy that down. And what we want to do here is we want to find the inverse. And recall the steps that we did last time. To find an inverse, we switch x and y. Remember that? I have to think back to like the first step that I gave you guys. So to find inverses, we go y equals. Remember that? We said, hey, just call it y instead of f of x. And then after that, you switch x and y. Remember that? I think I was even like sort of annotating the notes from the lecture. We said we find the inverse. So to find the inverse, you switch x and y. Right? We switch x and y. And now we're trying to get y alone. Right? So we switch x and y. We're trying to find the inverse here. And so why don't you guys add 8 to the other side? Just move that to that side. So it'll be x plus 8 equals 3 to the y plus 4. Why don't I just switch the left and the right? So this would be 3 to the y plus 4 equals x plus 8. Okay, so that's what I have so far. And I want y to be alone. How do I get y alone if y is upstairs as an exponent? That's when you go log to exponential or exponential to log. You see that? So right now, this looks like exponential form. So do what you did earlier in the lesson to rewrite this into logarithmic form. And if you write this in log form, it'll say log base 3 x plus 8 equals y plus 4. And now to get y alone, all you got to do is subtract 4 to the other side. And I can finish that on this side here. So to get y alone, right, to get y alone, subtract the 4. So that would say log base 3 x plus 8 minus 4 equals y. But don't turn that in on your homework or on your midterm, because this shouldn't be called y. It should be called the inverse of f, because the original function was called f. And so this should be called the inverse of f. Log base 3 x plus 8 minus 4. And that would be the inverse function. And it's not a coincidence that the inverse of an exponential became a logarithm, because they're inverses. Logs and exponentials are inverses. Okay, so one more for today. And our last example can be, instead of going from expo to log, let's do an example where we go from log to exponential. So let's wipe the screen clear. And let's take care of example B here. And then we can dismiss in this little tutorial, right? I'm not even sure who's watching this, but hopefully someone benefits from this. So let's start with this function here. H of x equals, let's go with log, let's go base 5. How about like x minus 1? And let's go like plus 7, something, just making this up. And we want to find the inverse. So pretend this says y equals. Okay, like that there. And we switch x and y. Okay, we go inverse. We go inverse. And we switch x and y. Right? That's always a key step, is when you switch x and y. That's when you obtain the inverse. But we do wish to isolate y. Right? We want to solve for y here. We want to solve for y. So why don't you guys subtract the 7 to the other side? So that'll be x minus 7 equals log base 5 of y minus 1. And then maybe I can switch the order. I like to have the variable that I'm trying to solve for on the left-hand side. So let me put the log piece on the left. And I'll leave the stuff with x's on the right. Okay. And then what we can do is we can write this into exponential form. We can convert this to exponential form. And that'll say 5 to the power of x minus 7 equals y minus 1. And then finish off this example by adding 1 to the other side. And of course, you want to use proper inverse notation. This should be called the inverse of h. And this here should be the finished result, right? Let's take one more look at this before we put our stamp of approval on this. And yeah, this looks good. So this will be called the inverse of h. So this video here, it's sort of a summary of our lesson, and it covered like 1/3 of the logs material. So on Monday and on Wednesday, we'll continue with logs, and we'll finish logs on those 2 days. So if you have any questions, please let me know. Have a wonderful day, and I'll see you guys next time.